Hello, everyone. Welcome to video lesson 1-3 on line segments. In your textbook, as you're taking notes, which remember are going to be formatted a little differently than you being able to see exactly what is in your textbook, but I will prompt you along the way. But we are on page 19 for your notes today. Our lesson goals for today, which you can always find in the sidebar on your page, are number one, calculate measures of line segments, and number two, apply the definition of congruent line segments to find missing values. So here we are in our learn segment of our lesson. Remember, there are four main parts to every lesson that you're going to have. The first being learn, then it will be followed by some examples of different types of problems for what you're learning, followed by checks, which are problems you will do on your own to check your understanding of how things are progressing for you in your understanding of the lesson. And then the final part of each lesson is practice. So here we are again at learn, and we're talking today about betweenness of points. So read along with me. It says a line segment is a measurable part. I'd love you to circle that word measurable right there, because this is the part where we start to use the building blocks that you learned about in video 1-2, points, lines, and planes. A line segment is a measurable part of a line that consists of 2 points, and those 2 points are called endpoints, and all of the points between them. The two endpoints are used to name the segment. So if you recall from the last lesson, we're going to use those capital letters, remember, to name lines. We're going to do the same thing to name a segment. For any two real numbers, A and B, there is going to be a number n between A and B, such that, and this is a double inequality, so we would say A is less than n is less than B is how you would read that, or in other words, n falls between A and B. This relationship also applies to points on a line and is called betweenness of points. Go back up to the top of this slide here where we're talking about naming the segment. Just want to remind you that back when we were doing our work with lines, that we had two capital letters that we were working with and a bar over the top. Back when it was a line, it had two arrows at the end. This time that bar at the top is not going to have any arrows because unlike a line, which is infinite in two directions, a line segment, to make it measurable, this is what we're talking about, it having end points. Okay, so a reminder that if we're talking about segment AB, that's the name of it. And if you see in print, just the letters AB, and they will be written in italics. I know that's hard to do with your own handwriting, but in your book, you'll see them in italics. That means we're talking about the measure in units. How long is that segment? What's the distance between the two endpoints? When you don't see the bar anymore, we're talking about measure versus name. So our key concept that goes with this concept of betweenness is that point C is considered between A and B if and only if A, B, and C are collinear and AC plus CB equals AB. Okay, so the two smaller parts added together equal the full length of segment AB. And that's important. Sometimes we're going to call this the segment addition postulate a little later on in the book, but this is the basis for that idea. Postulate is spelled like so, and it's just another fancy word for a rule. This is actually not going to be named this way in your book until lesson 3-5. So in case any directions or titles of practices refer to that idea, it's referring back to betweenness, okay? So here we are in example 1, and we're asked to find the measurements by adding. It says XZ is the measure of segment XZ. Point Y is between X and Z, and we're asked to find XZ by adding x, y, and y, z. I realize not all those words are on the slide, but they are in your book here on page 19. So we have a few prompts for ourselves, betweenness of points. And so we have our idea of betweenness being that the smaller parts, the smaller measures, if y is in between, then we say xy plus yz is equal to xz. That's already printed in your book. And so we're prompted to do substitution, and that's to take the values of those measures from the diagram. So xy we know is 11.3 and yz is 3.8. And of course that equals xz. And then we're asked to go ahead and add those two measures to get xz. So we're left with 15.1 centimeters. If there are units stated in the problem, make sure you state them in your answer. And once again, just note that when we're talking about measures, you have no bar over the top of the two capital letters. The name of the segment XZ has the bar over the top. So here we've arrived at a check for our lesson. We have a diagram that has a segment DF with the two parts DE and EF given the measures. We're asked to find the measure of DF, meaning the full length of DF here. So take a pause on your video and come back. And at the end of the video, you will see the worked out solution for this. Okay, this time we are asked in example 2, and I'm at the top of page 20 at this point. So in example 2, we're asked to use this concept of betweenness, but this time to find measurements by subtracting. It says point Q is between points P and R, and we can see that that's clearly the case from the diagram. So we have a couple of prompts here on this slide, and it says betweenness of points is the justification for the first thing that is written. You can see in your book that it's already there for you, PQ plus QR, the two smaller parts to the segment, are going to equal the full length of the segment. And then substituting the values that we have on the diagram, we have 6 and 5/8, that mixed number for the length of PQ. The measure of QR is unknown, so we're going to leave it alone. There's nothing to put in a blank there because that's what we're being asked to find. And so now we're going to go ahead and put in the substituted value for PR, which is the full length. You can see those arrows extend to the endpoints P and R in the diagram, which is 13 3/4. Now, I don't know about you, but with this fraction work, okay, we're going to want to make sure that we are working with common denominators. And so our 13 3/4, if we change that to an a fraction with just one numerator and one denominator, reminder that what we do there is take the denominator and multiply it by the full whole number of units. So 4 times 13 is 52. And if we add the 3 to it, we end up with 55/4. The other fraction that's used in this work is 6 and 5/8. And so with that same process, we're going to get 48 plus 5 or 53. But notice the denominator is different there. So we would want to get a common denominator in this 55/4. And that's going to be if we multiply both of those values, numerator and denominator, by 2. That will give us our 110 eighths here. So if we're going to find the value of QR, now we're going to use our concepts of algebra. And you can see in your book that the prompt that is there is to subtract your 6 and 5/8 from both sides, because what we do in algebra to one side of the equation, we always do to the other. But I'm going to suggest to you that it's probably a better idea to subtract that 6 and 5/8, not from the original 13 3/4, but by this now 110/8. So if we take 110/8 and subtract 53/8, we are of course left with 57/8. And let's go ahead and put it back into the structure of how the values are given to begin with, which is mixed number. So we want to ask ourselves, how many times does 8 go into 57? And of course, that is 7 whole times to get up to 56/8. So that's 7 and 1/8. And there, of course, we see that at the bottom of the slide is correct. Now we've arrived at a check for finding measurements by subtracting. This is at the top of page 20, right under the notes we were just taking. Go ahead and pause the video and see if you can take these decimal values and use subtraction to find the measure of what is missing, which is PQ is what they're asking you for. Okay, in example 3 on page 20, we're now asked to work with writing and solving equations to find measurements. Remember in the last video, I told you that your algebra skills were going to stay sharp as you're working through geometry. Here's an example of just that. So it says, find the value of x and BC if B is between A and C. Then we're given an algebraic expression for the measure of AB, and BC. So 4x minus 12, x, and 2x plus 3 are the labels that we're working with. The steps for your process are laid out for you here. The first step is going to be, if you are given only a verbal description of what is happening geometrically, you always want to make sure there's a visual that goes along with it. So they've drawn you a picture, a diagram of exactly what is happening here. We're told, remember, that B is between A and C. And then we are told what are the expressions for the measures. So we're labeling the segment AB, BC, and AC with each one of the algebraic expressions that we were given. All right, now we're going to use the concept of betweenness of points to go ahead and set up an equation that the full length AC equals AB plus BC. The next step of substitution, you can see your book has put in the measures that come from the diagram. So 4x minus 12 equals x plus 2x plus 3. And then we're going to combine like terms. So how many x's are on the right-hand side? That's 3 x's. Then our subtraction property of equality algebraically says subtract 3x from each side, or you can think about it as move your x terms to one side, and that would be x minus 12 would only leave the 3. And then, of course, add 12 to each side, and we get that x is 15. So when you get to the end of an algebra problem, it's tempting to think that you have your answer, but remember to go back to what they asked you to find. It said find the value of x and BC. So once we know our x equals 15, we're going to go back to what the expression was for the measure BC, which was 2x plus 3, and we're going to substitute in our value for x that we just found, which is 15. And then we will do the arithmetic to get to our final simplified answer. So multiplication before addition, 2 times 15 is 30, plus 3 gives me 33. 3. And so we would have two answer blanks on a quiz like this, one for X and then one for the measure of BC, the italic BC that you see here. And so we have two answers here. There's no check for this type of example, but that doesn't mean you won't have problems like this in your practice and on assessment. So make sure you can use the algebra expressions as well to use the concept of betweenness and get solutions to problems. Now we're going to talk about some examples of application of this concept of betweenness. So we're using the idea of the Seattle Space Needle. Daryl is visiting the Space Needle in Seattle, Washington. He knows the total height of the Space Needle is 605 feet. He knows the distance from the ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle. Help Daryl find the distance from the ground to the observation deck. So 10 feet more than 6 times the distance, but the distance that he doesn't know is our unknown. So the notes that you want to take down here on this page, notice there's four different steps kind of walking you through your process. This is page 21, by the way. You have a much better diagram than I'm about to sketch here in the margin, so forgive me for what you're seeing here. Here's our Space Needle, and we've got something like this for the shape. And I'm going to go ahead and give these labels for the different parts of our diagram. So the top to the ground is a known distance. But what we don't know is from the deck to the top of the needle. So since we don't know that, we're going to call that our X. That's our unknown concept. Because if you read the last sentence of a word problem, often in math, is asking you to figure out what you're actually solving for. So it says, help Daryl find the distance from the ground to the observation deck. This is going to be our unknown here, okay? Ground to deck, or G to D. What we know is that the total height is 605. So in other words, our GT is 605. Then we have this expression 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle. That's a unit that we don't know. So DT is X, but the ground to the deck, or GD, we can make an algebraic expression 10 feet more than, that means 10 more than is added on, 6 times the distance from the deck to the top, or DT. So 6 times X, since that's an unknown quantity. And now we can go ahead and use the betweenness of points. Point D is lying between point G and T here. And we can say then that our betweenness labels are that the measure of GD plus the measure of DT is going to equal the measure of GT. And you can go ahead and write this in the space that's next to the diagram there, or in the margin next to step 3, probably makes sense to do. Notice there's a box for the total. So that's going to be our 605. Put that in the diagram and also write it in the equation at the same time. So there's our box. We're going to have 605. And then we have two boxes. We've already given the top box a label. There's another box for GD. So that's our 6x plus 10. And now we're going to solve the equation. So 6x plus 10 plus another x equals 605. If we add our like terms, we will get from there 7x plus 10 equals 605. Subtracting our 10 from both sides, we get 7x equals 595. And then dividing both sides by 7, we get that x is 85. Again, go back to the last sentence. Make sure you know what it is you're actually solving for here. And that's the distance from the ground to the observation deck, or the expression for GD. So we're going to loop this 85 right back up into and substitute into this expression. So we're going to do 6 times the 85 we just found that x is, plus another 10. And that arithmetic comes out to be 520 units were given, so make sure you use them in your answer. 520 feet. You could also think about this as another way to go about it is to take our total height and subtract off the 85 once we know what x is, because you can see in the diagram that, of course, this distance, G to D, would be the full distance, but subtract that x. So you can go about it a couple of ways, by addition or subtraction, since this lesson has kind of gone over both. And that's another way to think about going about it, getting to that answer of 520. Okay, I'm at the top of page 22 at this point, where we're talking about line segment congruence. So it says if two geometric figures have exactly the same shape and size, then they are congruent. Bolded words all through here. Hopefully you've been taking note of. These are vocabulary words you would be expected to know. So it says two segments that have the same measure are congruent segments. And here's our diagram and kind of a visualization of this idea of congruent segments. Notice the symbol that we have here. I told you about geometry being heavy on both vocabulary and symbols. We have this new symbol right here. It looks like an equal sign with a squiggle over the top, and that's exactly how you would write it. Equals with a squiggle over the top there. But when you see it, you're going to read is congruent to. Notice it says red slashes on the figure also indicate congruence. I just want you to take note of the fact that sometimes and most often these are referred to as tick marks. And if you look in the margin at the study tip right here, you'll see that phrase as well, tick marks. On the figure also indicate congruence. So we see those tick marks written on segment AB and on segment CD in the diagram. And so we can say that those segments are congruent. You don't even need to have the measures. In this case, they're 1.7 centimeters there to say that they're congruent if the tick marks are present, okay? But they are going to always have the same measure, congruent segments. All right, so putting all the concepts from this lesson together, now we're going to write and solve equations by using congruence. So we're going to have algebraic pieces to this and using the idea of measures that are the same from congruent segments. It says, find the value of x if q is between p and r, pq is 6x plus 20, QR is 2 times the quantity x plus 6. And then we're told, here's our statement and our symbol, PQ or segment PQ is congruent to segment QR. Our instructions are to write the justifications in the correct order. And it says you may use a justification more than once. So you have your written in blue text in smaller print there above all of the steps written out for you, what each of the justifications are. This is going to be good practice. Justifying each step because we're going to develop towards writing mathematical geometric proofs. So we're told we have congruent segments. So of course that means their measures are the same. We're starting with PQ equals QR. So you can pull that justification down, definition of congruence, and write that in the blank in your book. Then once we know that, we're going to substitute their values. So we will go ahead and put in the 6x plus 20 that we were told the measure of PQ was, and the measure of QR is that 2 times the quantity x plus 6. Simplifying a little bit, distributing that 2, we get 2x plus 12 on that side of the equal sign. Nothing new to change on the left. Subtracting 2x from each side. And I realize how it's written in your book, but I'm just going to do this here. The simplification line should be 4x plus 20 equals 12. And again, you're going to want to make sure that you're filling in each of these blanks. So substitution, of course, the distributive property got us there. Subtract 2x from each side and simplify is where we are so far. I would also accept the wording here of adding like terms. And just so you know that whenever you have an each side thing happening algebraically, that can also be considered what we call properties of equality. So if you hear me say that you're using a property of equality, that means you're doing the same operation on both sides of the equal sign. So this would be first the subtraction property of equality, and then we're going to use that again, the subtraction property of equality here to get rid of our 20 or move our 20 to the other side. Simplifying that is where we have our 4x equaling -8. Divide each side by 4 is where we are getting to our x equals, or 4x equals -8, actually having that divide by 4 written in, and then our simplifying to x equals -2. Reminder to go back and look at what you were asked to find. In this case, you were simply asked to find the value of x, and so we're done here. A reminder that the value of the variable can be negative, even though we're coming from a diagram of a segment where, of course, a length would never come out to be a negative value. But that x is really only part of the measure. I'm just going to substitute it here into the expression for PQ so you can see what I'm talking about. This 6 times -2 plus 20 would still give me a positive measure for 8 of that segment PQ. So just because you have a negative outcome for your algebraic answer doesn't mean it won't make geometric sense. And now you have a final check here with example 5, using again the concept of betweenness to write an equation, and also congruent segments, that vocabulary word, that symbol coming at you. So take a pause on the video and do this last check, and then you will see the worked out solutions at the end for you. Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching. To find the measure of df here, we are going to use the idea of betweenness, that df is the sum of de and ef, oop, plus ef. There we go. Substituting in the values, we have 2 and 7/10, or I'm going to take dE and make that into 1 fraction of 27/10. And EF is going to be equal to 5 and 9/10 becomes 59/10. And that altogether is 86/10. But to put it back into mixed number form, that's going to be 8 and 6/10. And then we always want to make sure that we simplify our fractions. So 8 and 3/5, taking that 6/10 down to lowest terms. And there's your check for page 19. Over on page 20, we're using our concept of betweenness to again find missing measurements, this time by subtracting. Writing your betweenness equation here, you would say that PQ The unknown would be found by taking PR, the full length, and subtracting QR. PR is 24.3 centimeters, and QR is 17.8 centimeters. And so subtracting that, we get 6.5 centimeters. Here in example 5, we're finding the value of x using an equation. We're told that u is between t and v, and that tu is congruent to uv. So here's our diagram. And remember, we can put tick marks on these segments to show that they're congruent as well. The equation that would result from that is taking each expression and setting it equal. Then we're going to go ahead and distribute on the right-hand side. And we can subtract 4x from both sides. I always like to move my variables first so I can know which side they land on that will remain positive. Then we're going to subtract 35 from both sides. We have that 3x equals -7, and dividing by 3 on both sides, x equals -7/3, which is in lowest terms. No need to simplify that any further.